Akynes are hydrocarbons that have at least one triple bond. They are alicyclic hydrocarbons, and they have examples like ethyme, propane, both 1-ene, both 2-ene. And we have so many of them, but this ethyne is actually the most useful among them. And that is why we're going to look into the ethyne. I know you may be expecting me to go for the naming of compounds or naming of the alkynes. Okay, I'm sorry to disappoint you that I'm not going to do that in this video, because the same method we use in naming of alkenes, you can also apply it there. The only difference here is that you're going to substitute the ene to yne. So there's no need of stressing ourselves in going for how to name the alkynes and all the processes that leads to formation of the double bond or triple bond. I have done all those things in my beginning of my video. Therefore, if you are new to this video, I urge you to go back to my introduction to organic chemistry 1. Ethyne is the first member of the alkynes. The molecule actually, as you can see on the screen, is being composed of the sp hybrid of equivalent bond of 2 carbon atoms and 2 hydrogen atoms. If we look closely to this, you notice that the hydrogen is reducing. When we compare it with the alkane, the hydrogen is reducing. That means that the ratio of carbon to hydrogen here is increasing. That we're having more of carbon than hydrogen by ratio in alkynes. This has a problem in its chemical reaction. At least in burning, we're going to have a sooty flame or smoky flame when we are burning ethyne. Let's look at the laboratory preparation of ethyne. Now, when you have water and you add it to calcium carbide, it's going to be explosive, and it is possible that the heat might break the glass. Therefore, we normally use sand here to put it here, and we collect it through water, and the gas that comes out is ethyne. The chemical equation looks like this, and this gas is collected over water with a downward displacement of water. As it is going up, the water will be coming down, and this place is copper tetrasulfuric acid, actually acidified, to remove the phosphine that might be present, hydrogen sulfide that might be present, or ammonia that might be present in this calcium carbide. Okay, let's look at the physical properties of ethyne. Ethyne gives us a sweet smell if we are checking by odor, and it's actually a colorless gas. And when we compare it with air density, it is slightly less dense than air. If we compare it like that, looking at the relative vapor density of air to be 14.4, that of ethyne is 13, and it is almost insoluble in water. The melting and boiling point of ethyne are low. Let's look at the chemical properties of ethyne. Every hydrocarbon will burn in air, but their burning in air differs. When we look at alkanes burn with bluish flame, not smoky, not sooty, not luminous. When we compare it with alkenes, there is a little bit smoky. Now, when we compare it with alkynes, we are having much smoky flame. The reason being that as we move from alkane to alkene, the carbon to hydrogen ratio increases. As we move from that alkenes to alkyne, we are having more of the carbon to hydrogen ratio to be increased. I hope you know the general formula for this. Let's look at the second property, which is addition reaction. You can notice that unsaturated hydrocarbons undergo addition reaction, whereas the saturated undergoes what we call substitution reaction. I don't know if you noticed that. Okay, if you have not noticed it, go back to alkenes and look at it. You notice we have a substitution reaction, but here we are having addition reaction, and it is actually from this addition reaction that the unsaturated hydrocarbon can bond with bromine water, decolorizing it from its brownish to colorless. Hope you get that. One of the addition reactions that occur in ethyne is halogen addition. We can have something like bromine, iodine, or chlorine added. When it is being added, this is what we observe. If, for instance, this X is chlorine, we are going to call it 1,2-dichloroalkanes. If this X is bromine, we are going to call it 1,2-dibromoalkanes. If this is iodine, we call it 1,2-diiodoalkanes. Now, the more we add this, the name changes. The truth here is that these addition reaction will always remove the double bond or the multiple bond. For the first one, the triple bond is reduced to double bond. Then the last one remove the double bond to single bond or single. That is why if you check the name, here is E and here is A. I hope you get that. Let's try reaction with hydrogen. 1 mole of hydrogen will convert ethyne to Etym. If we have another mole of hydrogen again, we are going to have a conversion of this to Etym. Hope you get this. Okay. Here is nickel serving as the catalyst. And in my previous video on Akynes, I actually told us that this idea is, or the concept is applied in manufacturing of margarine. If it is hydrogen chloride, if we have hydrogen chloride added to this, first of all, give us 1 chloro Etym. But the more hydrogen chloride is added to this, we will have the hydrogen attacking this hydrogen side and the chlorine here. If you compare it with what we have in the previous work, we were supposed to have 1,2-di, but here we are only going to have 1,1 because the chlorine will be attacking that has less hydrogen, whereas hydrogen will be attacking that has higher number of hydrogen. So in step 2, we will have, since this is the place that have higher hydrogen, that is where the hydrogen is going to come over. So this hydrogen will go to this will go to this, and if you check it, it's chlorine being at one side of the carbon. This idea is coming out from Markovnikov rule. I hope you get that. Okay, one other reaction in this addition reaction that is very, very important is what we normally use to distinguish between ethyne from Etym. The reaction of ammonium silver triazonitrate 5 or ammonium copper 1 chloride with ethyne is actually used to distinguish between ethyne or the Akynes from the Akynes. Here, this will have a white precipitation, whereas this one will have a red precipitation of their acetylides. Okay, this one is going to be a white precipitation. So you have to know that. And I want you to know that the terminal hydrogen atom will act as an acid in Akynes. For instance, if we have something like this hydrogen here will act as if it is an acid. Therefore, metals can actually attack this and remove this hydrogen from it. So let's look at the uses of ethyne. Yes, by polymerization, we can actually get benzene from ethyne. I want you to know that oxyacetylene blowpipe flame, it is gotten from ethyne combined with oxygen, and this is very, very hot and it's normally used in welding, in melting metals. And we also make use of ethyne in ripening of fruits, and it also serves as a raw material for making some chemicals like polyvinyl chloride. Thank you very much for watching this video, and don't forget to subscribe and click the notification bell for subsequent video.